looking at the solution here, it's y equals minus 3x, and then there's 5x plus y squared equals 64. So this is if you look at this question now, you'll see how the questions that we've been working on really apply to this. You have to take the result of something and then throw it into something else, meaning this xy here, to get it. So you're solving this system over here. There's the best method would be a substitution because it's nonlinear. Nonlinear meaning there's a square here. So this is going to go here. That's a skill we've worked on quite a bit. All right, now I wrote this out, but it would have been way better if you could have just written the following: 2x per quantity squared, or you just squared it, all in one step. So it's 4x squared equals 64. It'd be way better if you can get down to any of these other two steps here.
Okay.
So from here, what say you? What?
Divide 4.
Yeah, divide by 4. So x squared equals 16. What does x equal?
4.
Or?
And negative 4.
Yes. Okay. We don't know which one is correct. Actually, it looks like they they were kind of nice here. They didn't include the negative as it. That's not the answer. And we can look at the answer space and say, okay, well, none of those match. So I either did something wrong or I haven't finished here. Y is equal to minus 3x. So y is equal to minus 3 times 4, which is negative 12. Okay. Or y is equal to negative 3 times negative 4, which is positive 12. Okay. So our solutions are, well, there's a lot of solutions here because we don't know whether it's 4 or negative 4. It's 4 comma negative 12, or it's negative 4 comma 12. In either case, what do these multiply to become?
Yeah.
Negative 48. Okay, so the skill here, and okay, so I have a question that is similar to this, that we could look at now if you want it. Or what I can't do is I can't make them up like this because this is their sort of format. But we can do one kind of like this if you want. I can pull up one and just kind of modify it slightly.
Yeah.
Okay, would that be useful or something else?
No, I think that's good.
Okay, so let me get to that place where I can do that. All right, this is question, I'm gonna 2-column, and we're doing, oh, it's not there. Okay, so this one is, let me get this, I'm almost there where I got something pulled up here. So I'm just gonna slightly modify this question, but it's the same idea. I'm gonna do it without answers to make it a little bit harder. But what you're doing here is you're using the result from solving the system. Instead of x minus y, let's just find x times y.
Okay.
So you're going to use this information to solve for x and y, and then put that back in to find x times y.
All right. So 9x plus 3. Plus 2. I don't know which.
So 19 times 6, it's awkward, right? But it's within. Go ahead.
I got that 144, but then it's 147 divided by 9. Is that what?
So you said you got 147. So that this right here though would be like if this were 20, it'd be minus 120. So it's 6 less than that. So minus 114.
Yeah,
And
I
then
got.
and,
Oh, it's
right, and then 9x equals minus 117. So this does work. And you have to think about it in terms of like, well, 9 times 10 is 90. So I know it's more than that. Well, how much is left over? 27. So 27 is 9 times what number?
3.
And then this is your solution here.
Oh.
So x is minus 13. Well, that's not what we're looking for again, though. It's minus 13 times 6.
So negative 78.
Good. Do you want to do one more of these, or do you want to move on to the next question on the practice test?
We can go to the next one, I think.
Okay. Pulling up question 8. All right. Okay. I'm just looking it over first to see if it's missing anything. Now I'm snipping it in. Get to where I can snip this in. Okay. All right. So this one says, in the xy plane, line L, which we don't have, contains the point 1, 3 and has a slope of 2. Which of the following? So when it says that, you got to look at the answers, is an equation of the line L. So notice that all of these are in slope-intercept form.
Mm-hmm.
So you have to go from, and there's two possibilities. You can go y minus y1 equals slope x minus x1, and then go to y equals mx plus b form. Or you can start with y equals mx plus b form, and you have to just manipulate it to kind of get what you want. My recommendation is to start here because it's you have a point and you have a slope.
Okay.
So let's try that here. So it's y minus 3 equals 2, x minus 1. And then all you're doing here is you're solving for y.
Okay.
So give that a try and see if you can come up with the right answer.
Plus 3. Y equals 2x plus 1.
Say that one more time.
Y equals 2x plus 1.
Yes, because it's minus 2, add 3 plus 1. That's your correct answer here. So, I'm not sure why you got it wrong. It doesn't really matter. You could, for example, because it has a slope of 2, you could actually eliminate those 2 right away.
Mm-hmm.
And then you could, like, if you get down to 2, I'm okay with kind of messing around with the answers. You could put in this point and see, does it work there? Does it work?
Okay.
Does it work there? The ones we've been working on have been a little bit more complicated because they're in different forms.
Yeah.
But you have to be able to move between the forms like we talked about here. So let's do another one here, just kind of related to this. Let me write it out here.
I know all these things, and then when I take the test, I just forget it all.
Yeah, well, if you play golf, and I mean, going from the driving range to the golf course is very different than
Yeah, exactly.
it's the same thing in this world. So the point -2, -3 is on line L, and sorry, it's not cursive, but we'll go with it, and has a slope of 1/2. Write the equation in standard form and determine the value of C. So this is just a little takeoff from what we just did, but what I want you to do here is see that you have to choose which form of the equation you're going to start with, which is either point slope form or slope intercept form. And I would recommend point slope form, but it's totally up to you.
-3. Okay. I got y equals 1/2 x minus 2.
Yeah, so we got 1/2 x minus 2. Now the value of c here, what that's referring to is ax plus by equals c in standard form. How do you convert this to standard form?
You move the 1/2 over, so it's that, but you can't have a negative, so you have to multiply. Oh, you can have a fraction either, so you have to
Nope.
multiply.
Good.
You get 2. So that would get that out. And that out. Okay, so it'd be x minus 2y equals 4.
So what's the value of c here?
4.
So the multiple choice might have been something like 2, 4, and then I don't know, something else that's, minus 2, minus 4. But the point of this problem is to be able to move between the different forms. All right, so the next one here is, so this one I can't do because it doesn't give me the equation. It wasn't even in the solution, so we're gonna just have to move to 11. This one refers to a graph which isn't there. Not useful. Yeah, that doesn't help us at all.
Sometimes they can't show the questions because of I don't know. They sometimes do that for my AP chemistry class. They're like, we can't show you the question because it's a secure exam or something.
I'm yeah. We'll just move to something else here, and
We can just hop around. I just thought that maybe it would be good to look at this.
yeah, this is definitely good. And I hope what you're seeing is the problems you've been doing have been harder. I know I keep emphasizing that, which should prepare you. The other thing is, like, this is a story problem, and we've done a lot of story problems, so um, you have a lot that that to draw from now. When I look at the answer space, and this is a technique that I teach pretty early on, if we were doing an actual class, not just one-on-one stuff, is you really should look at the answers and be like, what's the same, what's different? There's two questions: what's the same and what's different.
Mhm.
And like when I look at one and A and B, the only thing that's different is this part. Same thing with B and C. Or sorry, C and D. So we should figure out what goes there. Without even reading this, I can tell you that this is a PAT question. PAT is a growth or it's a decay. And I remember you had some questions at some point where it's like, based on the value of A, if A is between 0 and 1, it's decay.
Yeah.
And if A is greater than 1, it's growth. And sometimes you can just read that in here. Oh, it goes up every year. Well, that one's gone and that one's gone.
Oh, okay.
So now we're down to these two. And I mean, I don't remember if you're supposed to guess or not. I actually wouldn't classify this as hard because you're able to reduce the answers pretty quickly.
They don't count it against you if you guess.
Okay. So like if you can do stuff like this, that helps as well because it reduces your time, and we haven't even read the question yet. So now we'll do that. A scholarship program increases the total value of scholarships each year by 7% of the total value awarded in the previous year. For the third year of the program, the total value of scholarships awarded was 750,000. So you have to be clear on what that means. Meaning like in terms of this equation, what does that mean? Any ideas?
Uh, it's like a base.
It's a point. You convert the information there into an x comma y, but in this problem it's an n comma y because n is your independent variable. So for the third year, that means that n is equal to 3 and y is equal to 750,000.
Okay.
So you do not have a calculator, so it'd be pretty hard to put n equals 3 in there. But this one you can. Actually, I shouldn't circle that. That's not a bad thing to do. Here you can. Here it's 750, 1, 2, 3, 1.07 to the 3 minus 3 power. What is any number to the 0 power?
itself. No, one. One.
One. So this is 750,000 times one.
Oh.
Now I don't have one of these yet, but do you have a like a poster of math like concepts reference sheet kind of thing?
I
Anything like
yeah,
that?
I have like from last year. I have some like reference.
Okay, like this is one of those that it's like it goes in the corner or in a place, but it's like one of those that's super important. Another one here is that any number, I'm sorry, one one to any power is always one.
Uh-huh.
These are just things to remember here. Um, so, uh, and that's why letter D is correct. I'm sorry we got sidetracked. Um, what this problem is emphasizing, and I have one like this that we can do to kind of emphasize this. So let me go to all questions. Um, yeah. Okay. We've looked at this question before, but I'm going to focus specifically on the equation that is used here, and because I want you to see the importance here. So you can read this if you want, but the equation is W equals P times 8 to the minus T over 2. But T is really the number of years since a start date. Okay, so we can change this to minus T minus 2018, and they'll put a 1/2 out in front. So if T equals 2018, what does this whole thing equal? And you might say, well, that looks really complicated, Matthew. Well,
Uh-huh.
when this goes in here, this becomes 0. Any number times 0 is 0.
Is
And then
zero.
8 to the 0 is
One.
1. So this whole thing becomes P.
Oh, okay.
Okay. So let's say we'll just give you another example here. Let's say that the value of something that you want to buy as a function of time is equal to $10,000, and it's growing at a rate of 7% per year. If in year 4 the v of t, the value of the function is 10,000, we have to put something up here, something in this exponent, so that it becomes 0 in year 4.
Mm-hmm.
So would this work?
Uh, yeah.
Why? Why does it work here? What's going on in year 4?
It's um,
So when I say why here, what I'm really asking you to do is to say, okay, evaluate for t equals 4.
well, wouldn't it be one during that year? So it'd be
This part becomes 1,
10,000 in
which
year
is what we wanted.
okay.
So what if I take the same thing, but now I want it to be in year 2? What changes about this function that I just wrote?
It would be uh t minus 2.
Exactly. So this right here, this is called an offset from a base year. So the idea is like you've had these problems over the years where it's like let me just type one here. The price of bread has increased 3% for the last let's see 71 years. Write the equation for the cost of bread if it was $2.50 in 1950. Let me just make that a little bigger in case it's hard to see. Okay. So the idea here is that the price as a function of time, it started out as $2.50. It goes up by 1.03. Now we have a choice here. If I want to know the price in year 1951,
Mhm.
my exponent has to be 1. So how do you get that here? Well, you have to use this offset approach. This is what you end up subtracting.
Right.
So,
Okay.
so notice that if t is 1950, what is the price of bread?
250.
250. Okay. So what if I change this? Oops, I made a mistake. It's actually in the year 2005. What changes about all of this?
T minus 2005.
2005. So you're always subtracting that base year.
So then, if it was 2005, would you? What would? So you would actually have to do it, the equation. Then it wouldn't just be one, right?
Well, so you could make a substitution. Like you could say, oh, it's 1.3 to the power of t, but t is equal to the year minus your base year,
So
which
it's
is
2005 minus 1950.
if we go back to the original. I was trying to get what I'm trying to get you to see is this number changes that I'm circling. The base year changes.
Right. But I'm like, if it was
If it was 1950, that's 1950.
oh, okay.
If it's 2005, it's 2005. If I ask you, but then because I can ask you in a later year. Okay,
Hmm.
let's do this. Let's do this another way. So I'm going to give you the value of a scholarship. It's $1,000. One, it grows at 5%, and it's t minus 2020.
If it
So
was
what? Go
if
ahead.
it was the K, would it just be 0.05?
It's okay. So growth is 1 plus the rate,
Uh-huh.
and decay, which you're asking about, is 1 minus the rate.
Okay.
So no, it would be 0.95 if it went down by 5%.
Okay.
So what is the base year here?
2020.
So if I asked you, and I have to do some words, if I said, when was the scholarship worth $1,000?
1,000 minus 2020.
No, no, no. I'm saying, when is the scholarship worth $1,000? I'm asking, what value of t gives me just this?
Oh, uh, 2020
20,
would
20.
equal.
So I can ask the question two different ways. What's the base year, or when is the scholarship equal to $1,000?
Okay.
And it's the exact same question. Now, we haven't done this yet, but this is totally reasonable. I could ask you to figure out the value of the scholarship in 2021. And you might think, why I can't do that, Matthew? I don't have a calculator. Well, that this is a common thing for them to ask you. It's totally reasonable because it's just one exponent here. It's 1,000, 1.05 to the power of 1.
Right. That's what I was trying to ask earlier. If it was like
Okay.
the 2005, but I just couldn't figure out how to word it. So if they asked you like another value,
Yes.
okay, all right. So then you would multiply in that case just
Yep.
1,000 times 1.05.
Yes.
Okay.
So they sometimes do this. I've seen this where they say, you have $1,000 scholarship. It grows at a rate of 4%, and they want they want you to figure out essentially v of t. I'll just do this t minus 3. They want to know v of 3 plus v of 4 plus v of 5. Like they word it in such a way that they want you to calculate it in the base year, the next year, and then the next year. And it seems really hard. Like it seems like, oh, I can't do that. That there's not enough. I don't have a calculator. But if you see three gets you to this being what? What is this part when t equals 3?
Um, one.
That part is 1, so it's just 1,000. When v equals 4, it's 1,000 times 1.04.
And then it's 1.04 squared times.
And that looks really hard, but it's not as bad as it seems. Okay, um, so totally can be done. We don't need to do all this, but that's what I needed you to see, is that this is the progression that they ask you to do for this. Okay, let me jump back to your exam. That was question 13, so we're going up to question 15. Another one that says the given equation, which doesn't give it. I'm sorry, these are
All good.
okay. Um, I've seen this question so many times. This one that we're doing here. Um, okay, so it's okay. So here's one. I'll write the system. So the system is 4x minus 8y equals 12. And the other one is 4x minus 5y equals 24. So they're essentially asking here, solve the system, but give me the value of x. Okay, so pretty straightforward, right?
Mhm.
Well, if you use elimination, which is what you should do, if you use elimination, what ends up happening is you get y first.
Okay.
And that's why it's written this way. This is one of those examples where you have to make sure that your answer is actually what they're asking for. Because remember, we previously did one where it was like, what's x times y? Or I do it this way, x minus y.
Right.
So this is where you almost need to start with the question, what is the value of x? And then, okay, well, I need x, I don't need y. So um, if you do this with elimination, you can actually just subtract the equations. And this is something that most students are uncomfortable with, because the tendency is to say, okay, I got to multiply everything by a negative here, but that's slow because you've got to rewrite. So 4x minus 4x is 0.
Uh-huh.
Minus 8y, I'm going to write it, but it's minus 8y minus a minus 5y.
So minus 13y.
These negatives become positive, and
Yeah.
then you say it, 12 minus 24, right? It gives you minus 12. So y equals 4. Am I done?
No.
No. It's really easy to do that, though. It doesn't matter which equation you go back to. My guess is you probably put 4 in here. That's what I would think. So we'll go to the first one. 4x minus 8 times 4 equals 12. So the speed technique here is, I see that that's minus 32. I add it to this side. 4x equals what?
12 plus 32, which is
Yes.
44.
Yes. And then x equals 11.
Okay.
So here, I've got a ton of system questions. Let me pull some up here and see if we can get you to solve the system faster. And when you solve the system, it's always going to be, and I'll give you an example here. This system right here that I've pulled up, um, the best way to do it is to get rid of y, because you're going to multiply this top equation by 2 to get those to cancel. What do you think this question will ask for?
X.
Yes. And maybe it won't even ask for x. It might ask for, 3x. Let's do that. Okay. So I want you to solve this system
Okay.
and then figure out what 3x is.
-2?
For 3 times x or just x?
3 times x.
Okay, so x is a fraction. That seems impossible. Let me just check here. So minus 5x, I'm sorry, minus 10x plus 2y equals 12. 2x minus 2y equals 4. So if I add these together, I get negative 8x equals
Wait, I
6.
have to subtract them.
You subtract them when they're opposite in sign. So see how these are the same sign? I'm sorry, these are opposite in sign, so you add them.
Oh, that's why she messed up. I thought it was subtract them.
So let's just carry this through. So x is -2. I'm sorry, that I gave you the wrong information. It wouldn't ask for 3x. It would ask for like 3y. Because y is the one you eliminate first. So x is -2. Let's go back to this equation here. 2 times -2 minus 2 times y equals 4. This is -4. So when I add it to this side, it's -2y equals 8. That means y is equal to -4, but that's not what I want. I want 3y. So 3 times y is 3 times -4, which is -12. So here I've got a bunch more of these pulled up. Let's do a few more of these. Okay, so this is an example of one. If it was just asking you to solve, you could subtract. The reason you could subtract is because these are the same sign. If you subtract, you're going to find x. So this would never say what is the value of x. It would ask for what is the value of 2y.
Okay.
So let me know what you get when you subtract these. I'm going to just check that first, please.
Well, don't you have to like switch the signs then?
Well, I do them piece by piece. Like 5x, it's 5x minus 7x,
Okay.
and that gives you
-2.
2x.
Oh, I see. Because it's a negative, it does cancel out. Okay. And then -1 minus 5, 6 x. X equals 3. And then you go back and do -2y equals -1.
What did you get for x?
3.
3. Good.
15 minus 1. 2. 16.
So did you find y is 16 or y is 8?
Y is 8.
Y is 8. I agree. So then it's 16, like you said there. Let me find another one here. All right, so
I think I can find my original booklet from this one too and get the ones that like have graphs and stuff and send that to you maybe for next time.
that would be good. And that will help here. So this one, you would eliminate x. So I'll ask you for what is the value of -2x here?
Okay. 12.
So I don't have the answers, but negative 2y equals negative 10, so y equals 5. Is that what you got?
Yeah.
Okay. And then I'll put that back here. So this is 4y is 20, negative 12. So I get x is 6. Is that what did you get that also?
Oh, I got -6.
So it's 4 times 5 equals 8. So this is 20. When I subtract it, I get negative 12, negative 2x,
So it is.
x equals 6.
So it would be -12 then.
Yeah, so x is negative 12. Okay, let's move on to some calculator stuff here. It appears you have a lot more questions here. Just judging the first one here, some of these are pretty quick here. Uh, so this question, it says the length of line segment AB is 380. The length of line segment CD is 95% the length of line segment AB. What is the length of line segment CD? So if you were to write this equation, it'd say CD is equals 95% of multiply AB. So there's really only two ways that you could go on this. You could either multiply this by 380 by 0.95, or you can divide it by 0.95. Here, though, they're giving you the value, so you put it there, 0.95 times 380, and you have a calculator, so you can.
Oh, that's it. Wow.
That's it. Yeah, I mean, it's the type of question where I tell you, it's a variation on the following question. The list price of something you want to buy is $320. Okay. There's two possible ways that they can ask you. There's the discount question, which is you have a coupon for 25%. Okay. If you have a coupon for 25%, there's two things I could ask you here. How much do you pay, which is most common, which is not the 25%, it's 75%. Or I could ask you what the discount is. So if I ask you what the discount is 0.25 times 320. What you pay is 1 minus 0.25 because it's the other part of it of 320. The other type of question is the like the tax question, which is where it's an increase. Like I could ask you, I could say, well, tax is 15%. So I could ask you two things: how much do you pay, or how much is the tax? The tax is the easier one. It's 0.15 times 320. How much do you pay is the original amount plus the tax times 320. So notice all of these utilize that discount, like, or whatever I end up that number. It's just you're either multiplying, one minusing it, or one plussing it.
Okay.
Yeah. So do you want this one's I was going to say this be hard for us to do. The trend here, though, in the calculator section is that you did really well first 15, 16 problems, and then you didn't. Maybe you ran out of time. I don't know.
And then it's like all wrong after that.
I noticed that. Yeah, and I have no idea why, but that is the way it goes. Okay, so the next question here is a conversion question. They want to know which of the following lengths in centimeters is closest to 17.25 inches. So you always start with what the given quantity, and then sometimes it depending on how complicated this is, you maybe write out your final units over here to the right, but they give you the conversion. They say 1 inch is 2.54 centimeters. These cancel, and you're done. Just multiply those numbers together.
How did I get this wrong? I don't understand. Something so simple. Okay, so it's 2.43.82. So D.
Yeah. So the variant on this would be like, and we see this a lot in physics. A rocket travels at 215 kilometers per hour. What is this in meters per second? So this one's a little bit more complicated because you have to change both the numerator and denominator. So you have a choice here. Do you want to convert kilometers to meters or hours to seconds? And it doesn't matter because you can do them in either order.
Hours to seconds.
Okay, so 1 hour, and the reason it goes up here is because of that. An hour is 60 minutes. Now, it might be given. I think that's kind of common knowledge. But
Well, that's why I said, because I don't know what meters. Is it 1,000, right?
yeah, I'll give you that one. And then in a minute is 60 seconds. Okay, so see how the hours cancels the hours, minutes cancels minutes, and we're halfway there. Now, we definitely say that there are 1,000 meters in 1 kilometer.
Okay.
So you'd say, okay, I got 1 kilometer. I need that to cancel, and then 1,000 meters. Now, if you do this in your calculator, the bottom numbers here have to be, you might go like this: 215 times 1,000, and then it's divided by 60 divided by 60, or 215 times 1,000 parentheses slash parentheses 60 times 60.
Right. Okay.
There are ways to get this wrong just entering into the calculator.
Yeah, we did this in CAM before, so. Okay, so it's 215 times 1,000. 60. 60. It's 59.72.
Should be yeah, divided by 3.6. Yeah, so that's reasonable. Okay. So the conversions here are an issue. We'll get to that. Okay, so for next time, I would definitely ask you to send pictures of the ones we haven't done. We can spend some more time on this calculator section. I can't see I can't see any trends. I was just going through some of these questions here. But I don't see like anything obvious, like, oh, you need like a bunch of help in this area. Let me just pull up one more here to.
Those are all the ones with or without calculator that I got wrong. Well, the ones that we could see.
Yeah, we went through all the no calculator ones that we couldn't see. We're on to calculator now.
Yeah. Okay.
This is not a calculator question, and I wanted this. I just want to make this final point here. Almost all of the questions that are in the calculator, well, not all, most of the a lot of the calculator section is just by hand. They almost like, it's almost like a distraction. Use a calculator. This is nothing to do with a calculator.
Okay.
Here it has to do with knowing something from statistics, which is that the regression, I'm sorry, the slope of this line is positive because it's going up and to the right, which means that that one's out, but it could be this one, or this one. The, the challenge here is trying to figure out, okay, well, which points do I use to kind of go up and over kind of thing. But it looks like it's about a half. But the last point I'll make here is that you don't necessarily need a calculator to do these questions. Like the first couple we did, yeah, you need them, but some of the other ones are just it will distract you and make it slow here.
Right. Okay.
So let's pick up here next time with these questions. If you need another practice test for the week, I'd be happy to send you one. I don't remember if we're done with the most recent one I sent you or not.
I think I still have to do the third test, so I think I'm fine for right now.
Okay. All right. Well, sounds good. Well, thanks again for scheduling, and I'll see you next time.
Thank you. Bye.
Okay, bye now.